about the basics of the Keynesian consumption function and how to calculate things from it. So first, let's start off with why we need to use this. Well, it all begins with classical economics, which argued that in a recessionary, if an economy has a recessionary gap between its natural real GDP and its current real GDP, then the short-run aggregate supply would adjust accordingly to fill in this gap. However, Keynesian economics argues that sometimes this short-run aggregate supply won't change the economic equilibrium to the right place. It'll settle below actual equilibrium. And so John Maynard Keynes argued that it was necessary to actually change the aggregate demand instead of letting the aggregate supply shift itself to correct for the economic discrepancy. So to fix a recessionary gap, he says that you have to stimulate aggregate supply, or no, sorry, aggregate demand in order for the economy to correct. So think about what aggregate demand means. That means the stuff that you have in your GDP, right? So that includes consumption, investments, government spending, and exports and imports, but we're not going to worry about that for now. So all that equals to GDP. So we're not going to worry about this for now. We'll worry about that later. Oops. But the gist of it is that we need to affect these components of GDP in order to stimulate aggregate demand in order for it to shift to the right to fix that economic recession, right? And so the primary way to boost aggregate demand is to stimulate its most important, the biggest sector, and that is consumer spending. And so we need this consumption function because consumers don't spend all the money that they receive. And in order for us to determine, well, how effective will it be to increase consumer consumption, we have to realize that some of it goes into consumption, some of it goes into savings. So we have to use a function in order to determine just how much money is going into consumption, how much is going to savings. So what we do is we start off with disposable income. So as it turns out, as your disposable income increases, you'll have more savings. And so that means it'll be less effective in stimulating the aggregate demand if people save all their money, right? So that means the more people consume, or the more people earn, the more people will save. And so we use that to determine just how much money is needed to be added. And we'll talk about how to determine that later. But for now, we need to see just the changes between each level of disposable income, right? So what we do is we have this graph over here, and this shows the consumption function. The consumption changes in this model constantly, and so does the income. So what we want to do is find the slope of this, and that will tell us just how much people will consume as their disposable income increases. So why is this important? Well, if you stimulate the economy with way too much money, then it turns out that people are just going to save a lot of that money. And if they save it all, they're not going to spend it. And if they don't spend it, then it's not going to stimulate the aggregate demand. So what we want to do is find that sweet spot where just enough money is being given out so that people are spending that money, and we're giving out enough money so that we have people spend a certain amount, and that amount is what's required, what's intended to stimulate the economy with. So the consumption increases, right? Increases at a certain rate compared to disposable income. So because consumption, does the money doesn't all go to your income doesn't all go to consumption. That means only a certain part of it does, and we can see this rate is pretty constant in this model. So as we increase disposable income by 1,000 in this model, it increases by 750 each time we add $1,000. So that means for every $1,000 of disposable income you make available to the entire economy, you'll get $750 worth of consumption. And you could say this is billions of dollars instead of just dollars. And remember, disposable income in this case refers to the entire economy. So it's the aggregate disposable income of everyone in the economy. It's not just one person's disposable income, right? So on average, if you add $1,000, you'll get add $1,000 of disposable income. You'll add $750 of consumption, right? So it doesn't all work out. It's like an efficiency ratio. So this ratio is just the change of consumption divided by the change of disposable income. And it's constant in this model. It's actually not constant in real life, but to make it simple, you can assume constant in this case. So if you do the math, you'll find that between any of these, it'll be 0.75, right? Because like in this case, the difference between these two, 1250 minus 500 and 750, 1,000 minus 0 is 1,000, take 750 divided by 1,000, you get 0.75. So this ratio is the marginal propensity to consume, and that is basically what we're going to be using for our function's slope. It's basically how effective increasing disposable income will be at increasing consumption. So the higher the marginal propensity to consume, the more effective adding disposable income into the economy will be at increasing aggregate demand. So the rest of the money in disposable income is stored into savings. Okay, so you'll see that here savings starts out as negative, but it slowly increases to be positive. All right, and this is significant. First off, this means that if the disposable income is zero, so if someone makes $0, that means they still consume no matter what, because you have to pay for necessities like food. You can't live without food. Even if you're dirt broke, you have to get food somehow, so you're still spending money. That means you're losing your savings. However, at a certain point, when there is a certain point where disposable income is equal to consumption. All right. And so in this graph over here, what I have is the blue line represents y equals x. That's basically saying when consumption is just equal to disposable income. All right. And over here, this function is the real consumption function. C naught is the y-intercept, or b, and that just represents what is consumed when the disposable income is zero. This is called C naught stands for autonomous consumption. Basically, what you have to spend no matter at zero income. And then, as you can see, the marginal propensity to consume is less than 1 because you don't spend all of your money that you earn. And this graph over here, this line slowly increases, and it meets the point where disposable income is equal to consumption at this equilibrium spot. On this graph, it's pretty evident that the equilibrium is when disposable income is equal to 2,000. And that's when the savings is equal to 0. So basically, in order to calculate this, what you'll want to do is you want to set two equations equal to each other, just like you did in algebra. And you see these c's over here, you set these equal to each other, and if you do that, you'll get y sub d, disposable income, equals marginal propensity to consume multiplied by y sub d plus c naught. And you're solving for y sub d. You should be able to get the MPC data and the C naught data from the table. So figuring out these consumption functions requires some input data, and this data will be provided to you. So this is how you use the data to create a consumption function, and we'll then later talk about how to use this data to influence fiscal policy, or how to influence government spending in order to increase aggregate demand in order to recover the economy.